So if we're asked to find the linear function that satisfies these two conditions, linear should key something up in your brain. A straight line, that's y equals mx plus b. That's a classic example of something that's linear. Okay, so how do we get the y equals mx plus b for this function? Well, in function notation, it's always f of x. I mean, sometimes we use different variables, but typically it's f of x. So what's actually happened here is they plugged in a -3 in for x. And what they got out was an 8 for y. So it's a coordinate. Okay, this is your x, and that's your y. So likewise, this is going to be 1, 4. So to find out the linear function that goes for these 2 points, you have to find out the chief characteristic, the m first. And you might remember that as the y2 and y1 equation, the x2, x1. I think it'd make more sense to call this x1, y1, x2, y2, but it doesn't matter. Okay, plug them in your slope formula, y2 minus y1 over x2 minus x1, and you get 4 over -4. So I got a slope of -1 right here, -1. Okay. Now to find that b, you actually just have to take either one of these 2 points that you have. You can take this one, or you can take this one. Looks easier. Take this point and plug it into this equation. So on that point, x is 1 and y is 4. So I'm going to plug it in there. And then I'm going to solve that equation for b. Everyone and their grandmother knows that -1 times 1 is -1. So I add 1 to both sides. You get b is 5. So to finish out this equation, oh, come on. Do you ever wonder if it's a 4-year-old actually making these videos based on the chicken scratch? There it is. Y equals -1x plus 5, or y equals -x plus 5. But sorry, function notation. They said they wanted a function, so let's make it look like a function. There it is.